Hello. Now it is our last topic of this chapter and it is a cyclotron. Cyclotron is a device which is used to accelerate the charged particles like the protons, deuterons or alpha particles, or you can say the ions. It may be positive or negative to the high energy. Cyclotron was invented by E.O. Lawrence and M.S. Livingston. The cyclotron uses both the electric and magnetic field in combination to increase the energy of the charged particles. The working of the cyclotron is based on the principle that the energy of the charged particle is increased considerably by making the ion to pass through a oscillating electric field number of times with the help of the strong magnetic field. Oscillating electric field is an electric field whose polarity changes at the regular interval of time. Now see the construction of the cyclotron. Cyclotron consists of the two semicircular disc-like metal containers. These are called Ds because of their shape. These Ds are placed under the circular pole pieces of a very strong magnets. These two Ds are connected with the terminals of the high frequency and high voltage oscillator, whose frequency is of the order of few million cycles per second. This whole device is kept in a vacuum chamber. It is a front view of the cyclotron. Now see the top view of the cyclotron. These two are the D-shaped and these two Ds are kept at some distance along their diameter. Now see there is some distance between these two Ds and the source of ion is produced at the center. Now see this red point, it is the source of ions. Is produced at this point and under the effect of the electric field and the magnetic field it moves within the Ds and come out through the window. Now see the working of the cyclotron. A cyclotron, a proton, the source of the ion is placed in a gap between the two Ds. Say the D2 at that time is at the negative potential and D1 is at the positive potential. This one is at positive, this one is at negative. So the charged particle is accelerated towards the D2. And within the D2, there is no electric field. It is an hollow conductor from inside. However, the magnetic field is present in this region. As a result, the ion traces the circular path. And after some time, after tracing the circular path, it comes out from the D. Exactly at the same moment, D1 becomes negative and D2 becomes positive due to the high frequency oscillator to which these Ds are connected. Thus, the proton receives a fresh acceleration and enters in the region D1 with increasing velocity. As it goes inside D1, the electric field again becomes ineffective because there is no field inside the conductor, but the magnetic field again turns its path into a semicircle of increased radius. As it emerges the space between the two Ds, immediately D1 becomes positive, D2 becomes negative, and the particle gets accelerated again and its velocity is again increased. Again, it describes a semicircular inside the D and comes out in a gap. And this process going on. And ultimately, the particle comes near the edge and is taken out of the window. Now, the theory. The magnetic force experienced by the charged particle provides the centripetal force to the particle. And you know the centripetal force is given by the mv square upon r, and it is the magnetic force. So the velocity of the particle is bqr upon m, and the radius of the particle, if we look for the radius, then our radius is equal to mv upon bq. Now the time it takes to complete the semicircle. You know that the time is equal to distance upon velocity. Distance to complete the semicircular arc is pi r, and the velocity is bqr upon m. Now, time C, the time is independent. See, the time is independent of the radius and the velocity. It depends on the mass, charge, all are constant, right? As the time does not depend on the radius or the velocity, so it spans the equal time in a d, right? Now, t is the time period of the high frequency oscillator. Then for resonance, t is equal to 2t. By putting the value of this t, we are finding out the time taken to complete one circle, or it is the time period of the oscillator. Similarly, the frequency of the oscillator, which is the reciprocal of the time period, so it is bq upon 2 pi m. Now, maximum energy of the particle. The kinetic energy of the particle is half m v square, which is written in this way. Here we put the value of v. Now, the maximum kinetic energy of the charged particle is when r is equal to the radius of the d. When it is in the outer circle of the d, at that time the energy is maximum. So kinetic energy is half b square q square r square upon m. Limitations. Cyclotron cannot be used for accelerating the neutral particles because they are not accelerated by the electric fields. It cannot be accelerated to gain the speed very quickly due to the lighter mass of the electron, as it goes out of the phase and is very difficult to control. So electrons are not suitable to accelerate by the cyclotrons. Energy of the particle cannot be increased infinitely in cyclotron, as m varies with v according to the Einstein's relativity in this way. When v is comparable with the c, then value of m is very high. As the mass is increasing, and you know that the T is equal to pi m upon bq, it means the particle spends more time in the D, and it will not come out that moment the polarity of the D changes. So energy cannot be increased infinitely. Thank you and have a